Our first example, a rotating rigid body makes one complete revolution in 2 seconds. What is its average angular velocity? So we can use our definition from above. Angular velocity, that's omega. It's delta theta over t. So that's what we're looking for. The change in angle over time. 2 seconds, that's our time. That's pretty clear cut. It's a little less straightforward to pick out what is the change in angle. But if we read the problem carefully, we see it goes through one full revolution in 2 seconds. And so a lot of times with these rotational motion problems and ideas, it may not always tell us a number in radians, because sometimes it's more common to think of things in rotations or revolutions. And so here's our nice little conversion chart over here. So just remember, if we go one full orbit around a circle, that is 1 revolution. That is also 2 pi radians, or 360 degrees. So you just have to keep in mind that these are all equivalent to each other. So with the problem, with what we're given, it was 1 revolution in 2 seconds, but we can go ahead and convert revolutions to radians. I'm going to use this train track idea. So 1 revolution is the same thing as 2 pi radians. We see we just multiply by 2 pi, and our 2's cancel out, and we are left with pi radians per second. And so that is our angular velocity for this problem. You know, I didn't mention it in the last video, but now's a great place to do so, just because our SI unit for theta is radians. We won't have to change our calculator because we won't be doing sine, cosine, or tangent of these measurements. These are just ways to describe where on the circle, where in a rotation our object is. But we're not using trig with this. So we will be able to stick with calculators in degrees for our AP test. All right.